Can you hear me?
Hi, can you hear me? Yes, okay. What's going on with Alienware? All right, the quiz is available. I've removed the password, so you should be able to just get in and start it anytime you want. Again, it's open book. It is 30 minutes max, but you should be done much before then. All right. And the quiz is available. I removed the password, so you should be able to start it anytime. There's 30 minutes, but you should be done before then. Also, it is open book. You don't have to add quotations, double quotes, and no punctuation. And I believe if there's one input field, there should be just one word for per input field. Doesn't matter. Casing should not matter. And again, there's no password.
So here it tells us this rule regarding not having to put in primary keys. Does that apply for like the tables we did before?
Yeah, so it's basically telling you to ignore primary keys.
Okay, but tables we've seen before in this quiz, that rule doesn't necessarily apply.
Right. Yeah. This is just here. No, it doesn't matter. Yeah. You only need to do that if the names of the fields are the same.
Yeah, just making sure.
Yeah,
just
you don't need
clarify, you know what I mean?
Yeah.
Okay,
No.
cool, thank you.
Are you all done? You're done? Yeah. If you're done, please don't start a conversation. Yeah, don't ignore them. Things that ignore the for key, primary key. Okay, who's done? Who's not done? A few more minutes. All right, excellent. Let's get started. All right, let's see. So we're finishing up week number 6, and we just did quiz 4. So next week we'll have the exam number 1, and basically like a midterm, and so we'll on Tuesday we'll do a review. We'll take a look at exams from previous semesters, and we'll solve them here together. And you're welcome to take them home and do what you will and research them. And they're representative of questions from prior semesters. Some questions might actually be identical to some of those questions from that review. So that's Tuesday, and then on Friday we'll meet and we'll have that first exam. It'll be the whole lecture time, so an hour and a half, and it'll be just like one huge quiz, right? It'll take the whole hour and a half quiz. Same thing, right? Open book, all the slides, a lot of fill in the blanks, a lot of multiple choice, the same kind of instructions, right? To make sure to usually it's not case sensitive, no quotations, no periods, no colons, no semicolons, no anything like that, right? And usually just one word per input field. Okay. Also, a lot of the questions are randomly generated, so it's usually you won't have exactly the same questions as the person next to you. Again, to discourage you from collaborating. So that's all next week. When we come back after the exam, we'll start looking at some advanced topics such as object relational mapping, right? Of which perhaps today we'll get a chance just to do a sneak peek preview on that, and basically we'll start visiting some of the challenges that we have of converting the the flat representation of data in relational databases, right? Converting it into a non-flat representation, such as either an object-oriented language like Java or C# or any object-oriented language you can think of. We'll look at some of the challenges, and I am going to use Java as an example. We're going to give you lots of code for you to be able to work through this. We're going to handhold you quite a bit in these upcoming assignments. And yeah, so that's after we come back the exam. So yeah, so let's finish up this week. Any questions? The TAs have been regrading some of the questions from the prior quizzes. You had a lot of questions on question number 4, question number 1 for quiz 2 and quiz 3. So the TAs are working through that, and they should be done either today or tomorrow, looking at that. So just, and I think they'll let you know when they're done. Yes. Well, the first 2 homework should be all done. Yes. Yeah. Hopefully. Yeah. Yeah. The assignment 3, they're going through it right now. So hopefully this weekend. Yeah. Let's see. I thought I had released the quizzes. No. Let me see. Have I not? Yeah. So quiz 1 is available. Quiz 2. Yeah, the answers are available for quiz 2. Quiz 3. And quiz 3 is also available. So the answers are available for all 3 quizzes, and I'll release quiz number 3 later this weekend. All right. All right. So let me. I'd like to go over the assignment for this week. All right, so this assignment is going to give us a chance to practice programming the database, right? We talked about this week about using store procedures and functions, and earlier we had talked about views, right? So this assignment is going to give us a chance to practice those skills, right? And using the same database that we've been using throughout the semester, right? We're going to load the database. Either you can download from here. I have a hyperlink there. Unless you already have it from prior assignments. It's the same exact database, right? Although if you've broken it or you've added some data that might not work with some of the queries, you might want to just re-download the original database, right? Yeah. So with that database, we're gonna play around with answering 2 questions, right? So one of them we're gonna solve for you. I'm going to walk you through solving the first question. The second one, you're going to do on your own, right? Following the same steps that we did on the first one. So the 2 questions that are, which blogs are popular, right? And which posts are popular, right? So we're going to solve the first one for you, right? We're going to create a whole bunch of queries, and we're going to do a whole bunch of functions and store procedures and views to answer the first one. And then, having practiced through that. Hello?
Could you share your screen, please?
Oh, yes, thank you. Can you see my screen?
Yeah, thanks.
Okay. Yeah, so we'll answer the first question for you, how to implement and answer that, right? We'll create a couple of views. We'll, calculating a whole bunch of groupings and averages, and we'll create a couple functions to do this for us, right? And then once you've had the chance of practicing this, we'll ask you to do this on your own, the second one, okay? So for the first one, in both cases, you'll come up with two SQL files. One is going to contain all the work that you did for the first question, right? Which basically we're going to do it for you, or we're going to write it. It's all in the assignments. We'll walk you through the whole thing. Just make sure to walk through it, make sure that it makes sense what the results are, right? And then include it as part of your deliverables. And then the second one, popular post, is all you, right? Having all worked through the first one. Okay, so make sure you include both. We also ask you to export the whole database, right? Which includes all any tables you might have modified, any data you might have inserted. But in particular, we want to see the store procedures and the functions and the views that you wrote, okay? Right, because the assignment does ask you to write several of those. And if you remember what I mentioned last lecture, right, that by default, when you export the database, it does not include the view, right, and the store procedures and the functions. You have to explicitly make sure to ask to include those when you export it, right? I do have a couple of instructions at the end of the assignment on how to do that. Right, just make sure you go through that. Right, so basically 2 files that have these SQL statements, and then plus the exporting of the of your database. All right. Okay. All right. So the first question that we're going to solve for you is which blogs are popular. Yep. Although this is somewhat of it's a vague question, right? Because something obviously popularity is could be fairly subjective. Who likes what posts? So we'll have to come up with some formal criteria of what do we mean by popularity, and we'll just go by folks voting the blog to be, to have so many likes. Yes, and we'll calculate that a blog is popular if it's if its average number of likes is above average, right? Right. So we'll have to calculate what are the likes for each one of the blogs. We'll have to calculate what are the averages across all blogs, right? And then we'll have to identify which blogs likes are above average than all the blogs altogether. Make sense? So that would be the criteria. So the question might look like this graphically, right? If you have in the ratings table, so for posts, so for ratings, right? We can group by the posts, right? First group by the posts, because remember the blogs don't have likes, right? You can't like a blog. You can like a post, but you can't like a blog. Yes. So we're gonna have to aggregate first the posts, right, to see how many likes there are across all posts for that one blog. Yes. Right. And then be able to compare against how many likes does another blog have, counting how many likes do the posts are in that particular blog. Yes. So we can compare blogs with blogs. Make sense? Right. So notice that we have 3 blogs here, and we have 3 posts for each blog. So the calculation would be something like this, right? We have blog 1, blog 2, and blog 3. We want to be able to compare that which one is more popular, and so these are foreign keys that says that these posts, right, are for a particular blog. Yes, and these are other posts for blog number 2, and these for blog number 3. Right? And then we have for the ratings that we have that for post number 1 over there for this one, right? We have let's see, we have 1 like, right? And for post number 2 we have 1 like, and for post number 3 we have 3 likes. Yes. Okay. And these are all for each individual post, and so we can group them together and we give it a score, and then the average here is 1/3, 1/3, right? 2/3. Yes. Right. We can give it a score so that we can average out what it is, right? Same thing for each one across all the posts for all the blogs, right? These are the posts for blog number 3. These are the posts for blog number 2, right? And these are the scores, right? This is 100%, 2/3, 2/3, and so on and so forth. And we can group that together, right, by calculating the average of these, right? So the question of which blogs are popular can be converted into which blogs have an average number of likes higher than the average number of likes for all blogs. Yes, right. So that one question, which one is a popular blog, becomes this more nuanced, more detailed question. Yes, and so we need to identify, well, what is the average number of blogs for all blogs, and what is the average number for each one of the blogs? Yes. And then we can compare. Okay, which one has a higher average, greater than the average across all blogs, right? So this one question is converted into two questions. What is the average number of likes for a given blog, and then what is the average number of likes for all blogs, right? And then we can compare each one and filter out, which particular blog has higher. Yes. So those two questions can be answered with grouping and averaging and counting and all the things that we have learned on using select statements with group by and whatnot. Yes, and all the aggregate functions. So the average number of likes for a given blog, right? We can determine first the posts. We'll calculate. So we can say, well, let's look at first at the posts that belong to a blog. Yes. And so if we look at if we group by the a particular post, we can average out how many likes are in that post, right? And then if we find ourselves that this is actually a result that we might want to use to group together with a bigger query, we can create a view out of it, right? We can just wrap that one query with a view, right? So for instance, right, so if we can run this. So I think I have two posts, and it gives me that post number 1 has an average score of 75%, and the other one is 57, right? And I could treat this as a intermediate results that I can use in a bigger query, right? Perhaps to group by the blog as opposed to just the post, right? But this is only looking at the post, right? We have to group it together across all blogs. So we can grab that and create a view out of this. You say create a view, and I have a view here for you. And we can apply that, apply, and that creates a view. And there's our view right there, right? There's our view. And we can do the query. Notice that the query is exactly the same as our original query. See that? So it's being treated almost like a table, right? So you can say select star from a view, not a table. The table doesn't exist, right? It's a virtual table, right? So, all right, so now that we have the scores for posts, right, we can take that and aggregate it at the blog level. So we first aggregate at the post level, and then once we have the answers for the blog, for the post, we can then aggregate at the blog level, right, and just add everything up. Yes, across all the blog posts for a particular blog, and then we can do across all the blogs. Okay. Again, we try it out a particular query. We use a particular query to just look at the query that's going to group this by using a using the view we just generated earlier, right? So this is for let's use a roll up. Okay, we're going to roll up the post popularity up to their blog by grouping the popularities by blog. Right, so first we were grouping by post, and then we're going to be grouping by blog. Right. Again, we can group this together and put it inside of a view so that we can reuse it. So that we can reuse it in a view. We say create a view. We can post that in there. Apply. So now we have two views. Right, we have the likes per blog, and we have the likes per post, right? And we use to calculate the likes per blog. We aggregated the likes per post. See that? Right, because remember, you can like a post, but you can't like a blog, right? So you need to aggregate that, right? So finally, you can now use this query, right, to identify out of here what is the average like for each blog, right? So I can now ask, right, for blog number 2, what is the average number of likes? Okay, but now I have that information for every blog. Yes. So now I can ask, well, what is the average across, and then identify what is the total. Which one are greater than that, and so I can grab that query. Now I can grab that query and put it in a function. Right? I can say, okay, well, give me instead of me doing this query for block number 2, block number 3, block number 4, I can make that into a function that I can provide you the number, the ID of the blog, and then you can tell me what is the average like of the blog, and I can pass it to you as an argument. Now, right? I can pass it to you as an argument. Instead of me having to change it here, I can treat it as a function. Right? Once I can treat it as a function, I can use it in a where clause. Right? So, for instance, if I grab that function, right, and I create the function, and I paste that in there, that's a function. So now I have a function, and I can now call it. If you get an error, like we did on Tuesday, remember on Tuesday, it wouldn't let me create the function, right? And you need to run this in SQL. I thought I had done this already, where you need to turn on the trust of creating functions. So if you get that error, some of you might not get that error depending on the version of SQL that you have, but you might need to run this, which I did. So anyway, yeah. So yeah, we walk you through doing all that. Then on your own, following this example, after going through all that, you're going to be asked to do the same thing for posts. What is the most popular set of posts, right? And again, it's the average number of likes, and you're gonna calculate that, right? If we do ask you to create a couple of functions and also some views, just like we did to be able to answer this question, we created a couple of views, we created a couple of functions, right? So do the same thing. You'll create a view for the average score per post, which I think we did that for you already in the while we were trying to answer the question for the blog, we might have already answered this for you. All right. And same thing, the score for posts and then score for all posts. Okay. All right, then, okay, so that's functions and views. You get a chance to practice views and functions, all right? We then ask you to practice playing around with store procedures. Right? So functions are meant to be executed within a query, right? For instance, in our case, we use the, find the average likes for a blog. That's a function, right? And you give it the number of the blog, and it comes back with a value, and you could put that in a where clause. Yes, right? Store procedure are not meant to be used in functions. Yes. Which one? Syntax, was the error like this? Operation failed. There was a which one? This function? I believe I did. Yeah, I created it. Yeah, maybe it missed a semicolon somewhere. Yeah, we can take a look at it. Not during lecture. We can take a look later. Yeah, so store procedures are meant for they're written just like functions, okay, but they're not meant to be used in a query, right? They're not meant to be used in a select clause or a where clause. These are meant to be like scripts that you might run at the command line. It calculates something for you, right? Or even does some inserts and updates and deletes for you, and then it spits out the results for you. So it's meant for your consumption, right? It's not meant to be as part of a bigger query. Yes, right? So for instance, what we're going to do is that we're going to create a couple of store procedures that are going to implement what are commonly referred to as CRUD operations, right? CRUD means create, read, update, and delete, right? If you think of any table or any data model, right? Any piece of data will have basically those four operations, right? You're either going to create the data brand new, you're either going to retrieve that data that already exists, right? You're either going to update that data, so make some changes to data that is already there, or you're just going to remove that data, right? Those are the only possible four operations, right? I guess you can count one more is associate one piece of data with some other piece of data. That could be another one, okay? But basically those are the 4 or 5 operations that you could possibly do on any piece of data. Okay? So we're gonna play around with creating some of these pieces of well, I'll show you for blogs, and then I'll ask you to do it for posts, okay? So for one is find all blogs. That's these 3 are operations are also very common, right? When you're retrieving data from the database, you know, the 3 most common operations, right? In the CRUD, right? In the CRUD, they are the read. When you're retrieving things from the database, the 3 most common things you do is, one is give me all the data, give me all the records, yes, or some form of that where you're gonna maybe paginate through that. You know, give me the first 10 and then next 10, the next 10, right? So you're just paginating through a long list of data, yes, right? That's very common. The other most common is give me a particular record. Right? I know the ID or primary key of a particular record. Retrieve me that one record. Yes, right. So that's also very, very common. And the third most common is, well, here's a criteria, right? And then so retrieve all the records that meet this criteria. Okay, and which is, you know, I know the username and password of a user. Retrieve me that user, right? If it's and so I can check to see if I can log in, or you know, I want to create a new user, make sure that the user, I'm going to check if this username already exists. So that's the criteria, and it comes back with a record or not. So those are the 3 most common operations of reading data, and oftentimes they're referred to as finders. You find data based on some criteria, right? And usually the names follow that naming convention. You say find, and then the criteria. Right, the criteria here is all blogs, meaning no criteria, right? I just retrieve me all the records. I want all of them. The other one is find blog by ID, meaning I'm giving you a primary key and you're retrieving me that one record. And finally, find blog by whatever criteria you want, right? Here, I have a find blog by user, as in, or maybe by author, maybe it might be a better name. And, you know, find the blog whose author is whatever, right? Right, so those are very, very common read operations. You can have many other ones for yourself, right? That you might need in your, you know, to implement whatever app you're implementing. The other operations are also very common. You create a particular record, update a particular record, delete a particular record. Okay, those are also very, very common CRUD operations. And here's another one. You know, create random blogs. Right, I thought this one would be a cool one to do. This one just creates a whole bunch of blogs, right? But randomly, and you give it how many blogs you want to create. This is useful for testing, right? For you know, to generate random data, so you can, you know, test your application to see how it works with just random content. So let's play around with this. You know, later on in the assignment, you're asked to do exactly the same thing, but for posts. Right. So we first walk you through all the steps to do this. Right, and then it's okay. Well, now on your own, having seen how to do for blogs, go ahead and do it on your own for posts. Okay. So find all blogs. To find all blogs, the query is very easy, right? If I want to retrieve all the blogs, it's just basically select start from blogs, right? And that retrieves me all the blogs that are there. But instead of me, you know, typing the query, I like to have a function that I can run. Well, not a function, a store procedure, right? So all we do is just going to take that query and we're just going to wrap it inside of a executable, right? So that's easy, right? It's basically this. I'm going to copy that and I can say store procedure, create new store procedure, and I can paste that in there and say apply, finish. I can then try it by running it, right? It's saying, you know, call find all blogs. From here, something like call find all blogs. Right, and notice that it returns the same exact thing as if I would have run the select statement. See that? It does exactly the same thing, but now it's a function call. Sorry, a store procedure call, not a function call. Everybody okay? All right. So meaning, I mean, this one is trivial, right? It's just select statement, but I could put a whole bunch of loops in here and a whole bunch of whiles and if statements and a whole bunch of inserts. And I mean, I could make this as complex as I want, right? And then I can just run it just by calling that script. You should think of it as creating a script, something that I found very useful. I put it in a script and I can run it anytime I want, right? But these are some of the more common ones. Let's now do find block by ID. So let's do a create store procedure. Oops. So basically, this one's also very simple. It's the same thing as before. Select blogs for blog ID equal to, now it's a parameter I'm passing as an argument. See that? Right? So apply that. Right, and now I can try it out with, call, what was the name? Find block by ID. I can pass it an ID, run that, right? It comes back with that one blog. Yes. Or the author. I can take a look at the author. Right. Again, so this is a more generic criteria, right? I only want the blogs with that user. Okay, so you can try that out. How about create a blog for a user? So that's instead of being a select statement, then I'm inserting a brand new record. So I'm wrapping inside the insert statement, right? And what's coming in are parameters that would allow me to create a brand new blog, right? The user ID for the author, the blog name, and the topic, right? And those are the variables that I use internally in my store procedure. Yes. Update, right? Again, is I'm wrapping just a regular statement, update statement. I'm wrapping it with a procedure, right? That is parameterized. Delete, same thing, right? I can retrieve that one blog if I know its primary key. So here's an interesting one, right? This one is kind of like putting together a couple of examples, right? Create random blogs. Create random blogs. So how many blogs do I have so far? Let's see. So right now I have 1, 2, 3, 5 blogs, right? Blogs in there. And so in this one, I'm going to, if I want to try this out in my app, and one of the challenges for software developers and UI developers in particular is that when they're at the beginning of any project, they don't have real data, right? So they're not quite sure how they're going to lay something out if they don't have any data. All the lists are empty, all the content is empty. There's nothing to display, right? So they need some dummy data so the database can spit out some representative data that I can then render in my UI, right? So here's an example of creating random blogs. Let's just go over this real quick. So this says create random blogs, and then how many random blogs do I want to create? I'm going to declare a couple of local variables. One is going to be for like a counter, right? Starting at 0 is going to count 1, 2, 3, 4 until it reaches the number of blogs that you want me to insert. Then I'm going to create a random ID, right? So that I can come up with random names for the blogs, right? So it'll be something like random blog 32, random blog 134, random blog whatever. Yes, a random number. And then the random blog name will be the concatenation of this prefix and then the postfix, right? So here's my loop. Looping one, as long as 1 is less than the count, do the following. So it's a while loop basically, right? I'm incrementing the local variable. I'm calculating a random postfix. The random blog name is a concatenation of random blog and the random postfix. And then I'm going to use that as the name of my brand new blog, right? So I'm going to insert a brand new blog with the fields name, topic, and user, whose values are a random blog name, the topic. I'm a space buff, so I'm going to just put space in there for the topic, and then the user ID user is an argument. Yeah, so I can create it for an argument, right? All right. So anyway, so if I apply that, okay, I can now generate any number of blogs, right? So we had these, 6 blogs. We can call now this, or what did I call it? Call create random blogs, and how many I want. So I want 10 more, right? And user ID. I don't know the users. Users. So okay, so Alice is 1. So let's run that. And then let's look at the blogs again. All right, there they are. So generated 10 random blogs, inserted them with some random names, right? So now this might be useful for as I implement my user ID, my user interface, right? I can actually display some content, right? This is also useful for performance testing, right? They for testing they'll run this and insert gigabytes of data, right, to see if the database performs, right? Even though it might be very, very full, right? And then they'll have a whole bunch of threads hitting the database, simultaneously to see if there's any flaws on the queries, and look at performance of which queries are taking the longest, where are the bottlenecks, right? And then they'll try to optimize those particular queries that are taking the longest, right? But if you don't have large amounts of data, all queries will run really, really fast, right? Only when you have lots and lots of data, some queries are going to start performing better than others, right? You can like push those to the edge, right? Identify where the optimization has to occur. But for that, you need lots and lots of data. So anyway, so you can run this. I don't know how many I tell you to do. Maybe I do tell you to create 100. Maybe I don't know. I forget. Be careful. You can't get into an endless loop that's just going to keep inserting and it's going to crash a server. Okay, it's just going to keep inserting, right? And you're going to have to kill the database. So just be careful. So anyway, so having done that for blogs, we ask you to do the same thing for posts. Okay, on your own, right? Find a post by ID, find a post for blogs. Okay, well, this was a little more interesting, right? Find posts for blog, meaning giving you a blog, right? Find which posts are related to that blog, right? Okay. Then create posts for blog. Okay, again, so this one's a little more interesting because usually when you create a post, you don't create it in a vacuum, right? The post is for a particular blog, right? It belongs to some parent's blog, yes? Just like when we created the blog also has to be related to some user, right? Some user created the blog and now you're posting for a particular blog, right? So there's a relationship that you need to be careful there. And then we ask you to create random blogs, based on the example that we gave you earlier. All right. Okay. Also here a note at the bottom when you're doing the deliverable to make sure that you have all the 2 files that we asked for, right? Which is all the queries that we've been showing you all throughout the assignment. Yes, right. We want you to run all that and provide it as a deliverable, and also export the data. And when you export the data, make sure to include the views, to include the functions and the store procedures. Right. Make sure to include everything. By default, they're not included. Okay, so make sure you do include it. And then you can zip that up and have it just one single file. All right. Okay. Any questions on that? All right. Awesome. All right. So yeah, we had just started introducing the fact that not only do we want to be able to program the database, right, from within the database, we also want to be able to program the database outside of the database, right? Programming with store procedures and functions. I mean, that's as close to the data you're going to be, right? So any code that you write that runs in the database, that's as fast as you can possibly be, right? Because you're running in the same process where the data is being hosted, right? So you can't do any better than that. But nevertheless, right, all that is running. So that's a good thing and a bad thing, right? So usually folks that are going to be integrating with you or are going to be using your database are not going to have, you know, the authority, right, or the or not going to have the permission to execute those commands at the command line. Yes, they're not going to be able to do all the select statements. So we need ways to export or share the data with non-database users. Yes, we need them to be able to somehow log in, right, and have applications, right, that use your database, just like Workbench, right? Workbench, basically, it's logging into the database, right, into the remote server, right, and then sending all these queries, right, all these you know, select statements and inserts and updates. All these commands are strings, and they're being sent to the server. The server executes them, and then the server responds. Yes. Well, how do you write those programs, right? And so we're gonna spend today's lecture and a little more when we come back after the exam. We'll spend some more time. We're gonna dive quite a bit into it. Again, I'm gonna be using the programming language of Java. Again, I could have chosen any language. My understanding is most of you have some exposure to Java. You've done some, so I think it was a safe choice. But you know, I could have, you know, any language you could reproduce what we're going to talk about today in any possible language. And the vendors, whatever database you're going to be using, will have plugins, right? Will have drivers so that you can interact with the database with any programming language you choose. I'm going to be using the MySQL Java connector that's going to allow Java programs to talk to the database. Okay. All right. One of the themes that we're going to look at is the challenge between these two worlds, because the world of the relational database is very, very different from the world of the object-oriented world. Okay. There's some things are very similar and things that are very, very different. Okay, so we're going to try and take advantage of the things that are similar, right? And we'll have to just overcome the things that are not similar. Okay. All right. So I think did we create a project already? Okay, we did. All right. So this set of slides walks you through doing it in a particular tool that I'm going to be using. Well, obviously we're using Workbench, right, and MySQL, and so I assume you already have this. Now to talk to the database, I'm going to be using Intellij, right? And my understanding is some of you have already used Intellij for Java programming in the past. Not all of you. A lot of you maybe are doing using VS Code or Sublime or some other, and you can really do it with any IDE. It doesn't matter. You can just do it with Notepad. That's fine. So if you know your way around Java in general, you can use any IDE you want. Right. So if you understand class paths and jar files and you know all that jargon, you can use Notepad. I don't care. Right. If you don't know your way around some of the idiosyncrasies of Java, I suggest you use something like Intellij. Right. It's just a UI. You know, you download the libraries and it all works. Right. So again, if you feel comfortable and confident about Java and jar files and class paths and how to do that on your own, then go ahead. You can use anything you want. Yes. But if you're not as comfortable, I would suggest you use a full-blown IDE such as Intellij. All right. I'm going to demo with Intellij. Right. Okay. So. Right. So let's see. So let's we're assuming we're going to have a database. Obviously, we can create this just walks you through creating the database, walks you through creating a couple of tables. So for instance, let's create a couple of tables from here. Here's Workbench, and in our DB design database, I'm going to create a couple of tables. So let's see, new, create table, and this is courses. And so I'm going to have maybe course underscore ID. So that's going to be a primary key with an auto increment and the title for the course, varchar, that's fine. Let's say apply. So that's going to create a table. And so my courses, let's insert a couple of courses in here. So we'll say cs3200 and we'll say cs5200 and cs4550 and cs5610. Right, so we'll do an apply. So it inserts all those, perfect, all those courses. And let's just make sure they're there. There we go. So we have those courses in there. Yes? Okay. All right, so how do I retrieve this from a programming language, right? So let's see. So we created a table, we did some inserts, and we did, okay. All right, let's, also this walks you through creating a user, make sure that you have somebody you can log in as, which I do, I believe. If I go to administration and I go to users, I do have a cs3200 user, which I think the password is also cs3200. And this user has all the privileges. It has, it's a DBA, so it can do whatever it wants with the database. Yes, it can insert, delete, update, everything. Yes. So I'm going to log in as this person, but I'm going to do it programmatically, not from within Workbench, but from outside of Workbench. All right. All right, so let's just make sure that you have a user. All right, so let's create a project. So I'm going to create a project again using Intellij. So I'm just going to close this project. So project, new project, and it's a Java project. And I'm just going to take all the defaults. I'm not going to do anything special. I am going to say that this is, I'll create it under, let's see, NEU, CS3200, fall 21. The project doesn't create, doesn't exist. It will be created. Okay, create it. Okay, so the project is called CS3200 fall 21. All right. Okay, so once I have the project, again, this walks you through the steps in Intellij. We're going to have to download a library that's going to allow Java to talk to MySQL, right? And so one of the things that Java did, again, following kind of the same strategy that it was trying to do with the programming language, right? The idea of Java was, code once, run anywhere, right? That was its mantra. You can code on Windows, but you can run the same code on a Mac, unmodified. The same code runs everywhere. That was the intention. And so they're trying to do the same thing for databases, right? You code the same code that you write for MySQL will be able to run it just the same way without modification for SQL Server or Oracle, right? That was the intention. So what they did is they created a whole bunch of interfaces, and then they gave it to all these vendors, and it says, okay, MySQL, if you want people to write Java code for MySQL, then you have to write a plugin, right? And the plugin has to meet this criteria. It has to implement this API, right? And the same thing for Oracle. It is the same for SQL Server. You have to implement this API. The developers are going to write to this API. They're not going to use any of your local classes and your implementation. They're going to all the code is always going to compile against these interfaces, right? And that way, you can implement it in one architecture, but you can run it in another architecture. You can use one vendor and you can use another vendor. It doesn't matter. The same code runs everywhere. That was the intent. It doesn't work just as clean as they sell it out to be. You do still have to do a couple of tweaks, but for the most part, it works pretty well. So we're gonna have to download the plugin. The plugin is called MySQL Java Connector. Now, if you're not using IntelliJ, you can still download it on your own, right? If you're insisting on using Notepad or Sublime or VS Code, you can download the library manually from here, right? This is the, well, no, actually, this is, no, that's not what I want. Wait, what happened? Connector. Oh yeah, connector. This is the connector. Yes. For Microsoft or Ubuntu or Mac or whatever you can download. This is the latest version, 8.0.26. You download it. It's a jar file, right? And you have to make sure that jar file is on your class path, and that's it. Once your jar file is on the class path, you can compile against it. Yes. Or you can use Intellij and follow these instructions. Yes. Let's see. We can do for a project structure. You can go to libraries, and you can say, I want to add a new library from Maven. Maven is a very popular repository of libraries, right? Open source and private and for pay, right? And so any library that you can think of is available in Maven, right? If you go to maven.com, you can browse through their list of libraries. Everything should be there. So most vendors that write any library for Java will be available at Maven, right? So Intellij can download the libraries from Maven, and you just have to search it by a specific name, and the name is MySQL : MySQL connector Java something something something, right? So let's type that. So MySQL : MySQL connector. So it's searching. It'll take a while. I guess the more specific you give it, a connector Java. It's searching. There we go. Notice that it's the same latest version from the one I would have downloaded anyway, right? 0.026. Let's say okay. And it's adding it to my project, which is basically just adding it to the class path. That's all it's doing. It's downloading a jar file and it's putting it in the class path so that all my code will compile against it. So say okay. All right, so I'm done. Now I can start coding. All right. So let's see, what are we doing? So all the source is going to be under source in the SRC. And so let's create a Java class under here. And what do we want to call it? Let's see. So yeah, so these let's call it. So the naming convention in Java is that typically you put all your classes under a package, right? And the package usually is the reverse notation of a domain name, right? So for instance, if we were in university, it might be NEU, right? Northeastern, right? And then it becomes more and more specific, right? EDU, all universities, Northeastern University, right? And maybe a computer science, right? And then, or maybe Corey, right? And then the course, cs3200. I think that's it. What else? And then call this what? What do we want to call this? Do we come up with a name? JDBC package. Oh, DAOs. Right, and then I'm going to call it course DAO. All right, so DAO, as we'll see in a minute, DAO stands for Data Access Object. Right? I don't know have you seen software engineering yet? So in software engineering, one of the things that you learn in software engineering is that what are called design patterns. Right? So design patterns are a set of a collection of best practices that the industry has collected over the years. All right, and now all industries have design patterns. Right, so electrical engineering or chemistry or mechanics, throughout history, they've been building things. Civil engineers are the ones who came up with this. They've been building things for many millennia, and over all of that millennia, they've discovered things that work and things that don't work. Okay, and they write down the things that do work, right, and the right things that don't work, and in books, and then all that knowledge all goes to the next generation, right? And usually the next generation, reads these books and says, well, I should do this or I should do that. Yes. Same thing for computer science. And computer science is a collection of best practices that collectively are referred to as design patterns. And there's also anti-patterns. So design patterns are the things that you should do, and anti-patterns are the things that you should not do, right? And these are collections of things that engineers have tried over decades, right? And so that you don't have to reinvent the wheel, right? It says, okay, we were trying to do this, and this is what worked, and this is what didn't work, okay? So one of those design patterns is called the DAO design pattern, Data Access Object Design Pattern. And basically what it says is that if you're gonna interact with a database, right? If you're gonna access a database, you should encapsulate all that code, right, in a single class, right, or a set of very well defined classes that's all they do. They interact and they access the database. Make sense? So if we want to access, for instance, interact with the course table, all the operations that would have to be done to interact with that table would live under this course DAO, right? And what are the 4 things that we normally do with any table? We are going to create, we're going to read, we're going to update, and delete. Yes, those are the most common 4 operations. So this DAO class is going to host at least those 4 functions, right? We want to create a course. We want to be able to insert a course. We want to be able to update an existing course. We want to delete a course. We want to retrieve a particular course by its ID. Yes? So that's what's going to live in this class. Everybody good? All right. Again, we're following a design pattern. So I would say class. There it is, course DAO. All right, so let's see if this even runs. So if this is, I have my Java is a little rusty. Public static void main, I think it is. And we just print out to see if we are alive. Hello world. So main is just the entry point of any Java code, right? And we should be able to just run this. And it says hello world. Okay, so we are in the right place and it's running. Everybody good? All right. Okay, so what do we want to do? We want to talk to that database, right? So how do we talk to that database? Well, we need to log in. We need to log into that database and make a network connection to the server, right? Just what Workbench is doing, right? What do you do when you create Workbench? When you use Workbench, the first thing you do is that you define a connection, right? And in that connection, what do you put in there? You put the URL, the username, and the password, and I think the port. No, right? So we have to do the same steps that Workbench is doing, right? And then Workbench is going to log into the server, and then it starts interacting with that server. Yes. Well, we have to do the same thing. So let's declare a couple of variables that we're going to need, right? And just declare them here. So a couple of things. So one of them is the driver that we're going to be using. So we are going to be using the MySQL Java connector, right? And that it's already in, it's a jar file that we just downloaded, right? It's in our class path, and the point of entry into that jar file, there's one particular class in there, right? Called the driver, right? This is the driver that is exposed by the jar file. Yes, we need to instantiate it. We create an instance, and we'll see how to do that in a minute. We also need to, the URL of where we're going to be connecting, right? We know our database is running locally on our machine, so localhost is fine. I could have used 127.0.0.1, right? Or if this is a database that is running halfway across the world, right? And you know the IP address of where this server is running, right? If you know the IP address or the name of the machine, you could use that instead, and you would be connecting to that remote server running halfway across the world. Yes. Okay. But we know that we have a local machine, a server running our local machine. So localhost 3306 works just fine. The database, this is the schema that we're trying to connect to, and I think it's called DB design. I think that's what we called it, right? DB design. Yeah, so there it is. We need the name of that database that we're connecting to. What else do we need? We need this is just some configuration about the timing, the official timing that it needs to use UTC, universal time. And then username and password. I don't know if I have these usernames. I know I have cs3200, so let me use that instead. So that's how I'm going to log in with username and password. And I think that's it. Okay, we're done. All right, so what do? Let's connect to that database. All right, so we're going to need a couple of classes, you know, to interact with this database. One of the classes that we're going to be using is an object that represents the live network connection to the server, right? And in JDBC world, it's called the connection, right? It represents the current session that is a live session, you know, that we are talking in real time with the database, and that's the connection. Then we're going to need another one, a statement object that is going to represent the SQL statement that we're going to be sending to the server for execution, right? So this is going to be either a select statement, an insert, an update, you know, a string that we're going to generate and that we're going to send over to the server for execution, right? And then we're going to need also, what I don't have it here right now, is a result set. The result set is going to represent the response from the server. You know, when we say, you know, select star from blogs or from courses, right? It's going to come back as an array or some collection of objects that represent, each object represents a row in the original database. Yes, right? And we need to be able to iterate over that. Okay, so first of all, let's get a hold of a connection. And so let's do it right here. Say connection. Notice that it gives me access to java.sql, right? That's the one I want. Careful, there's a couple more, right? It's not this Jindy, right? It's not from Sun Microsystems. So it's this one. This is a connection. And notice that it imported it correctly from SQL. This is the package where all the JDBC code lives. All the interfaces are there, right? And so that's mostly what we're going to be using. So careful, because there is a MySQL version, all right, which you don't want. Okay. And then we're going to need the statement. There it is. Statement SQL. Okay. All right, so the first thing we need to do is load the driver, this driver. And we need to instantiate that driver. And we're going to do it using a runtime linking of the library. Right, so Java supports finding classes on the fly, right? At runtime, you know, finding these libraries, linking it at runtime, so that you can then instantiate it at runtime. So let's do that. So we can do this by saying, I believe it's class.forName. So I give you the name of the class, and it's called JDBC driver. So that's going to find it in the class path. It's going to load it into memory. It's complaining that this might throw an exception, I believe. So it's going to throw an exception. I'm just going to add it as part of the signature as a throw case here. Once I have that, I can now talk to the driver. Right now, I can talk to the driver. So driver manager, I can get a connection from the driver, right, by logging into the URL. If I give it the URL, and I give it a username and password. Okay, this is going to get the connection. And I guess I can put it here, right? Now if this succeeds, I am successfully logged into the database, right? And the connection object represents a live network connection to the database. I can start talking to it. I can start sending it commands, right? So for instance, I might say I create a string SQL command that says something like, select star from courses, right? And I can use a statement. I need to create a statement. So statement, or right here, yes. From the connection, I can create a statement. So connection, create a statement. Now I can execute the statement. I can say statement dot execute query. Notice that I have several executes. I have execute query. I can execute an update, right? If it's a query, it means that it's a select statement. If it's an update, it could be either an insert, update, or delete. Right, so execute query is only select statements. Execute updates are insert, updates, and deletes. Okay. All right, so I'm going to execute a query. I'm going to pass it the SQL. Okay, so this is going to send that string to the server for execution. Okay, it'll execute on the remote server. The server will go to the file system, it will execute, will return the rows, and that's going to package those rows and it's going to send them back through the network. Okay, and it's going to come back through this statement. So this statement returns a result set, just like the result grid in Workbench, the one that appears down below, which has the columns and the rows. Well, it's the same thing here, but over here is referred to as a result set. So this would be a result set. So these are courses, or let's call it results, or rows, I guess. Okay, so again, result set is also part of the result is part of the SQL package, right? So connection, statement, and result set are basically the three classes or three objects that you really need to interact with the database. Right, now that you have the rows, we want to be able to iterate over the rows, right? So we can say while, so rows, the result set is follows the collection or iterable interface, right? If you've seen that, I don't know. Okay, you haven't seen, maybe you haven't seen software engineering. The iterable interfaces are, as opposed to an array. Right? Array has a very well-defined size, right? It has either 100 elements or 200 elements. You know exactly the size. The problem with that is that they can't grow. You can't mutate it, right? Not easily anyway. Whereas iterable, you don't need to know the size of something that you're going to iterate over. Okay. And the way you iterate over is that you ask for the next element. You start the first element and then you say, well, give me the next element. I don't need to know how many there are. I'm just going to ask you for the next one. At some point, that next element is going to return false or something that lets me know that it's done. I don't have any more. Right? But there's no need for me to know how many there are, which is perfect for rows. Because I could have 100 rows, 200 rows. I don't know how many. Also, the rows could be tens of thousands of rows. Yes. So it would make no sense to instantiate tens of thousands of objects into memory. Because I might just iterate over the first 10 rows, right, and just throw away all the rest. Right. So the strategy here is that behind the scenes, there's a lot of magic happening, right? Where this result set is caching all these results, all these rows. As long as you say .next, it'll just keep giving you the next row. Yes. But it's not really going to instantiate all of them at once, right? It'll instantiate maybe 20 at a time, right? It'll bring 20 rows at once. You start iterating over them, and as you get to the last one, it'll ask for another 20. Right, and then you just keep saying next. Yes, and you can quit anytime you want without having lost any extra unnecessary instantiation of objects, right, and having depleted any RAM or anything like that. Make sense? So .next rows.next allows you to ask for the next row, and notice that I'm using it instead of a while loop, right? Now the while, usually the parameter of the while is a Boolean expression, right? So .next, what it does is says, advance to the next row and let me know if there's something there, right? If there is, return true, right? Meaning I have successfully advanced to the next row and there is something for you to consume, yes, right? And just keep going until there are no more rows and this returns false and I can drop off the loop. Make sense? Right? So now that I'm in the loop and this is successful, if I've advanced to the next row, I can now retrieve data from the row. For instance, I can retrieve the primary key, which is course ID, I believe it's called, right? So I can say, int course ID, I can read it from the rows. I am now sitting at the first row, at the first record, which has a course ID and a title. Yes, right? I can extract each one of the fields independently. I know the course ID is a primary key. It's an integer, so I can retrieve from that row the field whose name is course ID. Okay, and I can also retrieve the title, which I know is a string. So the rows interface has all the supported data types. See that? Notice all the supported data types, right? Get string, integers, arrays, ASCII, big, blobs, bytes, doubles, longs, dates, everything is there. All the basic, most data types supported by most databases are supported here, right? And it knows how to convert a SQL data type into a Java data type, right? It knows how to do the conversion. So if you have date time, timestamp or whatever data type or varchar, it'll know how to convert that into equivalent Java data types. Yes. .next. So .next does a couple of things. One of them, so first, when the rows come back, there's a cursor that keeps track of who you are in the row set, right? And at first, the cursor is not pointing at any one row. So it's I think the position is called before first, meaning I'm not yet pointing at any cursor, any row. So the .next advances the cursor. In this case, it would be the first row, right? If there is a row, it returns true. If there is no row, it returns false, right? So it advances the cursor and it returns whether there is a row to consume. So at the very last row, when you say .next, it advances the cursor, there is no row, and this returns false. And then you break out of the loop. Make sense? All right, so if this returns true, it means that we are pointing at an actual row and we can consume the row. Yes? And the way you consume it is with all these getters, right? You can get each one of the fields in the row using the name of each one of the fields. So this is a string, and so this would be a title. So notice that these are the names of the fields of the table we just created, right? In the courses, we have the columns, course ID, and title. See that? Right. So those are the names of the fields. Also notice the naming convention, right? Over here, we're using the literal names of the fields in the row in the original schema. Yes? Right? Using the naming convention of underscores and whatnot. Yes? But in the Java world, we're using the camel case naming convention, right? No underscores, right? And each word is capitalized except the first word. Make sense? Right? So we should make sense, make sure that we keep track of that. So anyway, let's print some of this, right? So we're going to say system dot out dot println, and we'll print the title. Let's print the title. So let's run this. And there they are. So we are printing out the names of the titles of the course. So we are retrieving the data from each one of those rows. Everybody good? All right. So now typically we do not want to just do this one-off connection and just throw this data and just spit it out. Typically we want to copy this content into some local data type, right, in our local application, right? Maybe display it in some user interface or whatnot, right? So we need to create a kind of an API to interact with this, right? So for instance, we had said earlier that CourseDAO should provide an API to interact with the database, and the typical 4 or 5 commands are, find all the courses, find a particular course by its primary key, right? Create a course, delete a course, or update a course. Those are the 4 or 5 operations that we typically have. So let's write one of them. So public, let's do static for now, and void find all courses. All right, so we could write this. We can copy this and move it over here. And I guess I need to, I need to add all those exceptions. There we go. So now I can just run it from my main, right? I can say find all courses. I can run that. That still works. All right. All the other functions that would live here are, public static void find course by ID, and you would pass me the course ID, and then I would run the query, and the query will look something like this, right? I can copy most of this, and the query would be what? The query would be select star from courses where my course ID is equal to, right? And we concatenate the course ID parameter. Yes, so that's the query now. Yeah. Now because we know it's only one, because it is a primary key, there's only one record. Yes. We know that this loop here, it's only going to execute once. Well, it should, right? If it's a primary key. Yes. So instead of a while loop, we could use just an if. Right? We know it's only going to execute once. It makes no sense to put it in a loop, right? But you still need to check to see, is there a row to consume? Is there a course that has that particular primary key? If so, retrieve it. And so I'm going to put it maybe, let's retrieve the title, and I'll spit out the title. So for instance, I can say, find course by ID and course number 2. And let's now do this one. If we run it, that'll be 5200. Yes. Other ones that we might want to do as well would be, for instance, public static void. We want to maybe create a course. Well, no. Let's do another one. Delete a course. Delete course, and you pass in the ID of the course that you remove, so course ID. So again, same connections. And I'm being lazy, but some of this code obviously could be put in a common place. So the query for deleting a course would be something like delete. So delete from courses where course ID is equal to course ID. See that, right? And so, but now this is not a query, it's an update. So we're going to do execute a query, execute an update, execute update, and there's a SQL. It doesn't return a rows, it returns an integer count. How many records were affected by this update? Right. So if there was 2 courses that were removed, count would be 2. If there's just 1 course that was removed, it would be 1. If no courses were removed, it would be 0. Yes. Okay. Obviously, because it's a primary key that we're removing it by primary key, count should be either 0 or 1. Right. So for instance, if we do a and this is a delete course, and I'm deleting course number 2, and then I'm doing find all courses, just to make sure that, to see if they're all indeed, I can do it before and after. and maybe a system.out.println. We can run that. So before we had 4, and now we have 3, right? And if we go to the to a database, it should be the case that the course table courses, if I refresh this, we only have 3 records left, right? So the update is indeed going in there. And finally, let's do one more. Here, we do we can do a create. Create course. The course that we are, since we're creating, we don't need a primary key because it's auto incremented, right? So but we can pass in all the values we need to create the course. So for instance, for now we just need title, and we would do it is also an update. So this would be so let's see, would be this would be insert. So insert into courses, so we just need the title, right? That's all we need. We need to put quotations, and we're gonna have to concatenate here the title, and then we execute, and this will tell me how many inserts there were. So let's try it out. So we're going to, instead of delete course, instead of delete course, we're going to insert a brand new course. So create course, we're going to pass a title, and is cs5550. So before and after, let's run that. Oops, you have an error on the SQL. Is my insert wrong? Insert into courses. You're going to see how to insert clipboard or copy to send to SQL editor. Insert. Oh, this uses the whole. Okay, I'll do that, I guess. Course ID and values. Title, values, courses, blah, 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 parentheses. Anything else am I missing? I think that's it, right? There we go. So notice that now I have this additional course in there. There are 5550. And finally, we can do an update. So let's do an update. So this would be update course. So update course. And for update course, I'll need the ID of the course that you want to update. So the course ID. And the new title, perhaps. And so this would be update courses. So set, and then title, and then the new value equal blah, blah, blah. And I don't need this. I think that's it, right? Am I missing something? Okay. And so I'm gonna change, and the idea of the new course that I just inserted was number 5. So I'm gonna modify number 5. Let's say this will be update course. Update course. And the ID is number 5, and I'm changing it to 7770. So let's run that. And there, oh, I changed all of them. That's not what I meant, right? We missed what? We missed a where, right? This is update where course ID is equal to the course ID. Yeah, course ID. There we go. All right, let's try that again. Let's change that to 888. Let's run that. There it is. So we changed the last one to 888. Everybody good? Obviously, you can have quite a bit of other interactions with this, right? Especially if this is related to other tables, like you have sections and courses, right? And you need to somehow relate courses with sections, that too. Obviously, there's a lot of other finder methods that you might want to have in there, right? You know, the courses that have so many seats available, right? And so you can have your own finder methods. Also, another thing is that notice that these are all static and void, meaning they can only be used in here. And so that's not very useful. So typically these return other data types that are useful outside of the of this course DAO. So for instance, final courses might return maybe an array of courses, where courses is a class which we instantiate, right? You know, as you read through each one of the records, you instantiate each one of these, right? You instantiate them into object instances of courses, put them in an array, and then spit out an array. That makes it much more useful, right? To just spitting it out to the console. We'll take a look at that a little later. But the intention of the course DAO is to sit between these two worlds, right? To convert a non-object-oriented world, convert it into an object-oriented representation, right? So that the rest of the application can treat the courses as if they were just any other object instance. Make sense? Right? And this class, or this object, right, is the only one who's responsible for doing the conversion between these two worlds, right? And the rest of the application should be, you know, unaware, right, that you're using a relational database. Okay, because if tomorrow you want to change to a non-relational database, the only place where you would have to modify would be this one class, right? And the rest of the application is unaware and it should not care, right? That's the beauty of creating these DAOs, right? It's a single point of maintenance, right? Anytime you need to maintain something, you just go to this one place. You don't have it spread over in the whole, you know, before DAOs, folks would have the code of interacting with databases all strewn across their code. And so, oh, I need some data in the database. They would make a connection, go fetch it, and have it, and then they would use it. And that was just a nightmare to maintain the code like that, right? Because, you know, everywhere your code, you have data connections everywhere, so it's awful. So one place, maintenance is great. All right, awesome. That's all I had for you. Any questions? Yes. Yeah, I'll make a Git repository and I'll post it for you. Sure.
Hi. I had a really quick question about the homework. The very last part of it where we have to delete all the ratings whose score is less than or equal to 3. I got this error message that said I copied it.
Oh yeah, same something wrong there.
Yeah, you're using the safe update mode.
Yeah, you have to. Yeah, there's a.
Disable.
Yeah, disable it. And just look it up. You are using the disables in the yeah. Just look it up in on Stack Overflow. Just how to disable that. And
Okay.
it's one. Just like we have to disable for functions. Yeah.
Okay, cool. Thank
Anything
you.
that is not primary key, they're
don't want you to
worried that you're gonna remove more than you think. Right? So they're warding you.
Thank you.
Yeah.
There's one what's the last lesson that's going to be on the exam? What's it on?
What we just covered.
Okay, and then yeah, so that'll be the Java code you post plus all the slides that are currently on.
Yes.
All right, great, thank you.
All right.
Okay.
Profe, una preguntita. Uno, yo vi que sale para el examen, que from week 1 to week 6. Y esto week 6. Por ende, lo vamos a terminar todo el martes.
Hasta lo que vimos hoy.
Okay, hasta lo que
Yeah,
vimos hoy.
only what we saw today. I mean, there's tons more with ENC, but only top today.
Entonces, we'll be like accessing through Java.
Sí.
uh,
Yep.
your
Yep.
data and everything, right?
Yes.
If there was to be a question on
Yep.